Hello, everyone. Welcome to the Podcast. This is Vaughn Vernon, your host, and I have today the privilege of talking to Carola Lilienthal, and she is with the German company WPS, Workplace Solutions, and I'm going to talk to her about software architecture and domain-driven design. So I'll let her introduce herself a little bit. Thanks for joining us.
Yeah, thanks for having me, Ron. I'm German by birth, and I've studied computer science in the 1999, 1995. I finished my my diploma, and I did a lot of software development when I was young. I programmed in Java. I even programmed in C# and all that stuff in the beginning. And today I'm managing the WPS company. I had the great chance to be in that group who formed this company in 2000 from the university. And I did my doctor's thesis quite late. So it was 2008 when I had already 40 years on my record. But this was cool because I could use my experience to write down what I saw in all those projects that I worked on. And I worked on complexity of software architecture, and this is now part of our company as a business. We create a lot of software. What we look at software as well for people to find out if it's complex, if it's sustainable, if they will live with it for a long time. So one part of my academic history went into this company as well, and I don't do this anymore today because I found my great interest in, of course, domain-driven design, but as well in helping my colleagues to develop in their career, to find out what they want to do. So I'm working a lot with humans today, but architecture is still my basis.
Yeah, so I think the word manager,
yes,
is sort of humble in German language. It probably means more, but you're sort of like the CEO. Right? That's sort of how to put it. So you wrote a book some time ago on software architecture, and it was specifically about sustainable software architecture. How did that come about?
Well, this came actually from my doctor thesis. In my doctor thesis, I still remember that moment when a colleague of mine who loved programming languages, and he said, well, I want to work on the question of complexity of programming languages. And in that moment, I knew, wow, this is my topic. I'm going to work on complexity of software architecture. This is it, and I started to work on the question, which kind of architecture is complex for programmers, for people, for architects, for humans. And I looked into cognitive science and cognitive psychology and asked myself, well, what are we doing as humans if we have to deal with complex stuff? Because, we both know, everybody knows, software systems are immensely complex with all those bits and pieces connecting, doing things. So, and I saw that cognitive science had ideas about what the brain is doing in complex situations. And humans had complex situations, all their development, they started with finding a way to Paris, how do I get there? Oh my God, there is some royalty family. How are they all connected? There was always complexity in human lives, and our brain started to develop techniques to deal with that, to not be overwhelmed. And this was really a great story because I could create a complexity model for architecture from this. We're gonna elaborate on that a bit, of course. And then when I started to work in the company, when the doctor thesis was done, and I saw that we can help people with this knowledge to know what to do with software, how to really construct it so that the next person will be able to support it, to maintain it, to extend it, to do all the things we have to do with all these legacy systems. And well, this is my love. We look a lot at old software and tell the people what we think about it and tell them what to do to keep on living with this system. So this is how I came to my first book.
Yeah, fascinating, actually, that study. So I guess this would overlap with socio-technical, or what I refer to more as social architecture. And maybe that's part of the book's message. And also, did it overlap with heuristics at all? Were heuristics
yes,
I imagine so.
Yes, absolutely.
And I think
absolutely.
I think what people don't understand so much about heuristics, like even in the DDD community, there's a lot of talk about heuristics and forming heuristics. Like, okay, this is my heuristic for doing this kind of thing, which probably the book offers those heuristics, but we kind of have built-in heuristics, right?
Yes.
So there's like when you're going to kick a ball, or or a ball like a foosball, right? Soccer ball is coming our way, we can understand immediately where the ball is going. And if it's anywhere near us, we can adjust our bodies to trap what's called trapping the ball, right? So, and why can we do that? It's because of heuristic that we have called the gaze heuristic. Yeah. And we don't even think about it. Like, we're doing no math evidently in our, or we are, but we don't realize how complex the math is, happening all at once. But this is something that we've trained ourselves to do through practice and so forth. So,
absolutely.
And there are other heuristics like that, which are just sort of like built in. And I had an interesting little exchange with Dave Snowden, the
cool. Wow. I know.
Guy. And he said that there's actually a line, I guess it's sort of a group of individuals who say that there is no real cognitive bias. We don't have cognitive biases. What we actually have are heuristics instead. Yeah. Okay. So they're looking at it more like fundamentally built in to us rather than heuristics are a shortcut, right?
Yeah.
So instead of saying it's a cognitive bias, they're saying, well, what we're doing is taking a shortcut to try to deal with the complexity of some situation, right? So part of these that we would normally call heuristics, cognitive bias, if you look at them as heuristics that are sort of built in or natural, it helps us to maybe not look at the people who are experiencing those or using those at some time as like, oh, you're uninformed, or you are, no, you're deeply informed. You're, and this is your life experience that's causing you to take this reaction. So I think it's a more positive way of looking at it. That's a very good point. I never think about it as positive or negative or whatsoever, but you're right, because what I tell people as well in my talks or in this book is we have 3 wonderful mechanisms in our brain that help us to deal with complexity, and they fit so perfectly with architecture principles, heuristics, that it's really easy to explain. You just have to know it. And what our brain is doing actually is, when there is complex stuff, we do three things. We start to do something that is called chunking, which means that we try to abstract, that we try to put things together in a whole and say, well, I don't know the details. This is just it, And this is a great thing, but it only works if the things that we try to chunk are related, if they have to do something with each other, So I always try to say to people, if you see a picture
of a seal lying on a beach with some stone next to his head, it's near, but you can't chunk it because, I mean, what should you say? A seal on a beach with a stone. I mean, this is not a great chunking name, you know? You need things that are related with each other. This is the idea of chunking. And if you think of software, we are talking about the same thing. We want modularity. And in the modularity, we want high cohesion and low coupling. And this is just it, you know. And then if you know that our brain is searching for this, you know, I want to chunk, click, click, then this is wonderful, you know. Or I say to people, imagine I'm speaking to you and I have a water pipe coming out of my shoulder. You're looking at me and you're saying, what? She's the speaker with the water. What? You know, it's sort of,
we don't know how to deal with it. Yeah. We don't know how to deal with it.
We have to construct, I mean, software that is easy to comprehend in all its complexity need to be modular in this sense, you know? Things, I mean, you can't build a manager class with methods for printing and for sending events and for whatever on, you know? This is not modular. And, you know, if I tell this like this, it's very obvious. It's clear, you know, and it's connected with our brain. This is the first point in this whole story, you know. And then I say, well, our brain loves hierarchies. We can remember much more if we have a hierarchy, one word, and other words underneath. So this is something we like. We like hierarchies. We should do this in software as well. We shouldn't create cycles all over the place. This is as well related to modularity, of course, because from my point of view, cyclic models don't have anything to do with modularity. You know, the basis class knows something from others that are stacked on top. This is not good. This is even not modular. You know, and the last thing our brain is doing is really the most wonderful thing ever. Our brain is all the time trying to work with schemata, which means that our brain has ideas about things. This is a cat. This is a dog. This is a that. And we have variations of it. And this makes us much quicker. This helps us to recognize, to deal with the world, you know. They did a wonderful test, the cognitive scientists. They took a chessboard and they put all these figures on the chessboard, and they showed it to people who don't know anything about chess. And they said, well, look at it, try to remember where they are, those, you know, little figures there, and then we take them off, and then you have to put them back, how much you remember, you know. And they did it with people who don't know anything about chess and people who are chess experts. And the result was that the chess experts put twice as much figures back on the board on the right place than those who didn't know anything about chess. But only then if the setting on the chessboard was something reasonable, something that would occur in chess. If everything was mixed around in nonsense, they did the same. The experts weren't better. And the cognitive science said, well, this is because they have schemata about chess. They can remember more about what they see because they use their schemata to. And this is great because in huge systems, you have to remember different things to find your way around. And, well, we do that in software. You know it. No, we have design pattern, architectural pattern. We have schemata. And we have to use them everywhere. And DDD is doing that. You know, we have building blocks. This is exactly what our brain needs. And I always tell people, well, this is a treasure in your architecture. I always ask them, do you have patterns? Do you do that? You have to work on this treasure to get everybody to know it, to have all your system in patterns in the end. Because our brain loves it.
Yeah, and I think, drawing the example of a chessboard and trying to remember the positions, probably the people who are unfamiliar with chess are looking more at the shapes,
Yes.
and instead of what they mean and the situation of the board, right? So where are we in this sort of battle? And and immediately a chess sort of expert, or at least someone very knowledgeable of it, they're looking at the situation probably more than the pattern of it, and or the visual of it. And I think, if I understand where you're going here, it also means that like a consultant who has, or a person who has a lot of experience with architecture will walk into a situation that they are unfamiliar with, and they will say, yikes. Whereas someone else who's been working in this for many years, and they've dealt with the, chaos or of the situation, well, they see it and they say, well, it's not difficult for me. But bring someone else new onto the team, just hire them, right? Bring 5 people, and what happens? Their brain explodes, right? They cannot deal with it. They have no way of reasoning about it in the way that this very experienced person does. And likely, if they weren't working on it for the past 20 years, let's say it's existed that long, what they're not admitting is how difficult it was for them to learn, I guess. So having a fresh set of eyes on something and taking recommendations from those who have experience in doing things modularly, for example, then the organization that's benefiting from that experience, or could benefit from that experience, should sort of let go of the situation of the chessboard, right? And just look at the shapes. And
exactly. So this is what we are doing in our company. We have standards of patterns or building blocks, if you want to talk in domain-driven design. And of course, we are doing domain-driven design, so we have that. And this is what we do. It's not possible to create new patterns just out of, this is what people doing, I'm sometimes, last days I was in a company, and I looked at their system, and I told the architect, well, listen, you're doing design patterns. This is great, but there is a lot. It's like 60 different patterns. And they are so similar. This is not a good idea. You have to sort of get down to a base. And he said, well, I understand. But, our programmers, they are artists. They need to create new patterns every year. Otherwise, they don't love to work anymore, and they're not motivated. And I said, I understand, but this is nevertheless, this is not a good idea.
But the hose coming out of the shoulder pattern just really isn't very good.
So I'm a big fan of patterns, you see.
And a pattern is a sort of heuristic, so our brains can understand them. So this is really what you've been discussing. I wanted to ask you about the cognitive psychology behind software architecture, and that is what we've been talking about. So
exactly.
So how do you think then? We have just discussed a little bit about the benefits of applying that, but let's say that we have a way to deal with the complexity and using, I guess, copy mechanisms in our brain or something like that. Can you explain how that might work?
I don't know if you have ever experienced that, but the other day I was with a young colleague searching a bug in some system, and we came from the model view controller into the service. And these were all patterns very common to our kind of construction, how we do it, And then all of a sudden we came into a class that was called service supporter. And we looked at it, and this is just the point. It was something unfamiliar to us. Somebody named a class somehow. I mean, we could explain ourselves what this class was for, but we didn't know. If you think about pattern, you know what the job of a class is. This is, you know the modularity. A service is doing this, and an entity has this job, and a value object has this job, and the connections, the coupling between those classes is restricted. A value object will never call a service. This is forbidden. Doesn't exist. And if you find that, this is a problem. So you know what all these classes should do. And if you come across a pattern, or even a class that doesn't even show a pattern, you don't know the constraints of this class. And this stops the flow, because you're in the flow. Model view controller and a service. What is this? What does this mean? What is the role of this class in this structure? And then you have to look inside, Oh, yeah, see, the other day we ran into a factory class. And, well, everybody knows what a factory class is. We looked inside and we saw, this factory was calculating. It was storing data into the database. And if you do these things in your architecture, you miss using patterns, or you don't use them at all. This whole part of structure, knowing roles of classes, is all gone, and your brain is just trying to figure out what this is sort of, and all this help is gone. And this is why we benefit a lot from it in programming, in developing software. Absolutely. Does this come across? Why I mean this helps?
Yeah. So what you're saying is, I guess maybe in terms that I think about this, is our brains have these three sort of natural, complexity copying mechanisms, and so if we align the solution with what our brains are good at, right?
Yes.
Is that sort of the way to put it?
Yes. Yeah. It makes us so much quicker, because in the end, it's about performance, about being able to quickly repair, change, think about, extend software. This is what we want. Yeah. Good. To understand it as well.
Yes, absolutely. So sustainable architecture and domain-driven design.
Yeah.
Let's think about how those might be related. And I just want to say, I don't know why, but I continuously see these, different people describe DDD as a methodology. DDD is not a methodology. And I hesitate to even try to give it a definition, because maybe but I would say DDD is, first of all, a philosophy. I think it's also a set of guiding principles and a set of tools.
Yeah.
And the tools actually that we use, some of them are kind of irreplaceable, because they do align well with our, complexity copying mechanisms in our brain. But others, for example, there is no, in Eric's book, the Blue Book, we don't read too much about function. We do see side effect free behavior, and that as an operation, but functional programming wasn't something that he really wrote much about. And yet you can still apply domain-driven design or implement domain-driven design using a functional programming language, no problem. But you aren't going to really have the aggregate pattern, because the aggregate pattern deals with mutability, changing the actual state of the object, whereas the goal of functional programming is not to modify anything, but to always create new things. And so you would create a new thing with the new effects. Not effects, but what the if we were thinking about an effectful architecture or programming language, even we would modify, we would affect the state directly, but instead we would replace the effects with changed data, in essence. Right? So then, okay, so how do we get sustainable architecture with DDD, I guess is the...
Yes. So, I mean, from my point of view, DDD makes just excellent use of these basic principles that I was talking about, modularity or cohesion and coupling and my love for patterns, I mean, it's all there and it's funded in the domain. And I mean, there can't be anything greater than that, Of course, if you talk about sustainable architecture, what I'm doing, I don't talk so much about the domain in the first place, I'm talking about cohesion, coupling, and patterns. But if I want to create software that someone really can use, I mean, I can't walk around the domain. I have to be interested in that. And this is the name of my company, Workplace Solutions. We are creating solutions for workplaces. So we are absolutely interested in the user, what he is doing, why, how, and all this stuff. So for me, the domain is actually the natural driver to get cohesion and coupling right. You can't. I mean, you can try to do it technically, but I saw that people were looking at cycles. I mean, I see huge cycles in software systems, like 5,000 classes all in one cycle, horrible things. And people try to cut them where there's not much coupling, They think this is a technical solution, but it's never a good solution. You have to look at the domain to understand what this is done for, which pattern are there, and then you have to cut in the right place. And it's often somewhere where there is a lot of coupling because someone didn't understand how to do it. So for me, this fits wonderful, together.
Decoupling is not an arbitrary decision.
No.
Yeah. And so, well, then how did you see DDD kind of arise in your career? Did it just sort of,
very good
the two
question.
things coincided, or?
Yeah, very good question. So I was raised in the University of Hamburg, and we had a professor, Heinz Züdekhofen, who wrote the object-oriented construction book, which is really old and all this stuff, who created, at that time, already in the 90s, tools and material approach. The idea was that users should work with materials, and they are using tools to do that. And we had domain values, and we had material classes, and we had service classes, and we had tool classes, And 2004, I was doing my doctor thesis, and we had pattern in this tool and material approach, obviously, because we had material as a pattern for classes. But I came across Eric Evans' book. It was, another language, we called it a language for architecture construction, a pattern language in the end. Here's another pattern language. Wow. And we started to compare them, and it's really not so far away. So the name tool and material approach was not as tempting as domain-driven design. So at some point in time, we said, okay, actually, what we are doing is domain-driven design, and we just use these names today. And we often look at that and we say, well, someday we have to get this tool idea, into domain-driven design. We have to do that someday.
I'm glad that you actually see domain-driven design in terms of how it's presented in Eric's book as a pattern language, because that's how I recognized it immediately. And I've even talked to Eric about that. And he said something, I don't remember exactly, but it was like, well, if I was writing this book in the 90s, it probably would have been a pattern language, but he was definitely influenced by pattern language. You don't see really the same, let's say, template for patterns that in his book, but I think usually those bold statements are ended with therefore. Right. So this is a pretty good clue that we're going to solve a problem in a reusable way. Yeah.
I met Eric once, but I didn't really talk about it with him about it. One concern that I have with all this, because the thing that he told us is you have to use the language of the users. This is what you have to do, the domain language. And calling his patterns building blocks didn't use our language, the language of software developers. He should have called it pattern and a pattern language. So, and this is sort of a twist, and I'm, but I love his book, I'm not, it's not against it, but you understand what I mean?
Well, I can't speak for Eric. I can only tell you what our conversation was, but I imagine there must have been maybe something like he may not have wanted his book to be connected with this long line of pattern books. And I even recall in 2003, 2004, I talked to some patterns authors, right? Or actually pattern book authors. And their advice was not to write patterns anymore because patterns were it was too crowded, and it was like already all the pattern books have already been written. So I don't know if that influenced his decision or whatever. I didn't, go into that any further. But also, I don't want people, when I talk about domain-driven design, I don't want them to know it only as a pattern language, even though it clearly is, but it is more of a philosophy. It is more of a set of guiding principles. Even though patterns are guiding principles, they are, and they are tools, still it's a whole different way of thinking, at least if you don't come from, like this sort of, I'm going to say, I think that the small talk world and
yes,
and that's where patterns came, right? and that's where patterns came from. A lot of people working in the early patterns were using small talk.
Yeah.
And so this sort of way that you develop software with small talk, which I was doing in the late 80s, early 1990s. And it's like, it's actually, when I saw Eric's book, I just connected immediately with it. So many things were already familiar to me. And I think the thing that was so sort of radically different was the bounded context. Even though we had divisions, they weren't driven by the language itself. It was, I guess you could say it was, but it was sort of the logical separations of where things seem, the different services needed to be. So, but giving those things names, that's become very important. Yeah. Whether or not people like those names, I'm not bothered by the names at all, because we have names to use. So that was a very important contribution to software development in general.
And what we had at that time was something we called the U architecture. So we had the idea that the technique is a U shape. Now, today we think about hexagonal architectures, but we had a U, and inside was the domain. So we were talking already about separating the technical part from the domain part. But in there we had the domain model, and then different sort of bounded contexts, but the domain model was one. And this idea to have bounded context specific domain models, this was a real eye-opener for us at that time, to do that, to have that and to have strategic design and all that part. So it's a wonderful book, and we learned so many things, from that, and recognized things like you.
Yeah. And I don't know if this, I don't know if Amazon is still using these little sort of robot things. They're able to go around the warehouses and like elevate themselves and pick boxes off of high shelves and things like that, and just bring them for packaging and deliver or, shipping. And, but I was talking to someone probably 15 years ago or more, and they said, "Wow, what a domain model that must be." And from a DDD perspective, I said, "Do you mean domain models?"
Yes. Yes.
So, that's a real difference. Like you're saying,
Yes.
there were some like, let's say some small talk models that were just enormous. I have seen small talk models that are, or even Java models that are like 500, domain objects, like
Yes.
500 aggregate roots. And you would even call them aggregate root because in using top-link, if you ever used top-link, it was the root entity, right?
Yes.
So I don't know how much kind of influence those technologies had on that,
Sure.
the definition of aggregate. But, when I saw aggregate and the aggregate root entity, I was like, oh, you mean like top-link root? So, yeah, it was just kind of like, oh, I recognize this quite well. So, what do you think is, I don't know, maybe we've sort of talked about this, but what do you think is really the essence of the import of DDD in, let's say, in your business or when you talk to colleagues? What is that real benefit?
Yeah, well, for me, I love three. There's three things. The first thing is that we really have to understand what the user is doing. The domain knowledge is the most important thing to create good software. A lot of techniques, we developed things as well, but this thing that said, well, stop. I mean, I don't know if you know this, but I once came across a cognitive concept that said, if you try to talk to someone about something and you use a method or a diagram form or something that only you have the model monopoly on it. You have a monopoly on this knowledge, and the other side will not be able to give you profound feedback. They will look at that. If you're creating a model, a database model, and you show it to the user, they will say, oh, they did a good job, quite complicated. I don't know anything about it, must be right. And then someone says, they said it's okay, and we go on and we build this thing, and afterwards the user is saying, well, this is not what I need, and just to, as a software developer, get out of this idea that we are the model creator, but we have to go there. We have to talk to them and understand their language and take this language as it is and write it down in texts or in domain stories, Henning and Stefan are doing, or in event storming, whatever. So to have a model which is easy, I mean, a model to get the model, the domain model, a modeling tool to get close to the domain model that is easy to understand and that the user can use as well, and where he can say, this is not right. I'm not doing it that way. There is no event like this. There is no connection in the domain story like that. This is so important that he really pointed us down to this understanding idea, to this profound knowledge that we have to go there and talk their language. So this is the first very important thing for me. And then strategic design, we already had this, wow, you can cut down a domain and construct the software like this that is heading towards loose coupling and high cohesion. And then the tactical design, but we had patterns already before. So this is how I do my priorities with DDD normally.
Yeah, and I just want to say too, your comment about I like three, in for something like decorative, what do you call it? Like, well, if you have a home decorator, let's say you hire a consultant as a home decorator, do you know what they tell you? Always have an uneven amount of objects on a surface. Always.
Okay.
If you have 3 objects on a surface, excellent. If you put 4 objects on a surface, it's sort of like it tells our brain, I don't like that. For whatever reason, we recognize it as, and if you have 5, that's good. But now 7, that's probably too many. It's still uneven, but it's like 7, I don't know, 3 or 5, that's good. 1, actually, that's an odd number too. But 1, not too interesting. No. So 3 or 5 is pretty good. And isn't that interesting how our, just visually when we see it, it's like, wow, that's pleasing. I like to look at that.
And I guess 7 is not so good because our brain is not able to calculate 7, to see it, Our brain has its limitations. And 3, and 5, we get it. But 7, is it 6 or 8 or what is it? It's a bit like that as well.
And then we have to count them. We literally, to know how many, we have to say 1, 2, 3, 4, 7. Yeah. So very interesting. So let's get into a real interesting topic right now about legacy systems and legacy modernization, right? So I have to say that every client or potential client that I speak with today is dealing with the legacy replacement, right? Part of me says, well, legacy replacement is really difficult, right? If you just start with, let's take this huge big ball of mud monolith and we're going to replace it. That often doesn't work out very well. I'm not even sure that it ever works out well. So how do you deal, how can DDD and the kind of 3 complexity copying mechanisms in our brain help us with modernizing legacy systems?
So in my first book about sustainable software architecture, we created a measurement. We called it Modularity Maturity Index. And with this measurement, we actually measure systems. So we look for modularity, we look for hierarchies, we look for patterns, and we have various criteria. This is all out there. People can read about it. The whole algorithm is defined, so it's not a secret what we do. And we give, companies are calling us to ask us, well, where are we? Are we good? Are we bad? They are complaining. Our programmers are complaining. Architects are complaining. But it works. So do we have to? What should we do? And we give them something from 0 to 10. 10 is really great, and 0 is really bad in modularity and maturity. And from there, from where you are, so if you are between 0 and 4, you can't just start to do strategic design and cut the thing into modules. You're far too far away. And if you're between 4 and 8, you can do some things. And if you are on the level of 8 and to 10, then it's easy. You can just cut it into, easy, but you can start to do it. You can start to think about it.
Your brain can deal with it, whether you're successful in the big pic, or actually in the tinier pictures, then maybe not.
But domain-driven design offers us various things. So in this, when the software is really in a bad state, we actually start with trying to get people to do tactical design. The first thing I try to give them actually are domain values. Value objects, Sorry, it was my word for it, but it's the same, I want them to start to increase the domain knowledge in the source code. And if you have all kinds of strings and characters and ints and floats running all around the place, and you start to replace them with value objects, the source code gains domain knowledge. And this is sort of, I start to try to give them little help, when they are in such a bad situation. And if the managers are saying, but you told us you're going to cut it into a thing, I say, well, listen, you are down there, and you spend 10 years of a team of 30 people to get there. I mean, I'm not coming with some secret miracle medicine.
Can I tell you, if I had €1 for every time that someone wanted the magic wand over their big ball of mud, it's like they think, okay, I teach a 3 or 4 day workshop and I consult with them for a week, and wait a minute. We didn't get anything. Well, first of all, you're trying to do too much all at once. Yeah. Right. You can't just succeed with that. No. So there's a whole set of steps to succeeding in that way at all. Yeah. And it's not starting. Yeah.
No, and I tell them as well, look, if you want to change your organization, it doesn't work like in 5 days neither. It takes time. You have to. And this is with the software the same, and I actually start with these basic things, and I tell them as well, how many unit tests do you have? I mean, test optimization, where and then 10% or something. I mean, what should I tell them? Change your architecture? Wow, it's
no change. You got to have tests first, and
yes.
So yeah. Now, this is interesting because you and Henning Schwentner are working on a book to get. Now, so our background is that you and Henning translated Domain-Driven Design Distilled, my book, to German.
Yes.
Yeah.
Yes.
So thank you again.
It was a pleasure.
and then Henning and Stefan worked on domain storytelling together.
Yes.
All of you, in the same company. And now you and Henning return as the dynamic duo. So now you're working on this book about legacy modernization.
Yes.
Like, okay,
exactly.
How do you actually do that? And I'm going to guess that there are some patterns and heuristics involved in that. And I think maybe your book will end up in my series. Is that true?
I would love to.
I'm very excited about that. So tell us about the book.
So, I mean, Henning and I wrote this first book about sustainable software architecture. There is already some DDD in there. There are like some chapters of DDD. And the German company, D. who did my German book and as well the English book, actually, they said, well, Carola, you have to write another book. It's time. And I said, okay, but it must, I want to do something with domain-driven design. Yes, wonderful, do so. And then at some point I said to Henning, well, listen, all the consulting, it's you, it's Stefan, we have to do it together. And then Henning and I just started. And it took us a lot of time because this was, my first book, there was already the knowledge. I knew what I was gonna write about. I had my doctor thesis, and it was quick. It took me half a year, and this book was done. And I was working on it was just weekends and stuff, and holidays. And this book, and now this is the second book that I wrote, and I felt, wow, this is annoying because it takes so much time. So the German, we started 2 years ago, and we handed in the German version beginning of March, just before all the health problems I had. It was exactly the good point, but it was really, really stressful to get to that point because this was all new. The text was new. We had to write it down. We had to think about it, everything. So what is in there? There is a first, we start with complexity because, I talked about it already. And I love this subtitle of Eric's book, Tackling Complexity. This relates my whole, it says a lot. And so we start with complexity, and we start to look at complexity, at essential and so at complexity that is in the heart of things, that is essential, and complexity that is just there and you don't need it. It just came in because you did something wrong, or like this. And then we look at all the things we have in the problem space and the solution place to reduce this complexity. And we start just with in the first 3 chapters, we just explained domain-driven design, collaborative modeling, so domain storytelling, event storming, and all that stuff, and architecture principles. And then we go into the second part of the story, and there we are speaking about the things you have to do before you can do strategic design. So. And then there's a last part about strategic design. And in this middle part, we talk about some things that I already mentioned, like, well, start with some domain values, get your infrastructure right, all these things that people have to do when they have legacy, and then they can show this to their boss and say, well, but they say it, you have to start, and you have to have a continuous integration chain, and we have to have some tests. This is the basis. We can't cut this thing into bounded context before we don't know, before we are not safe with our source code. And then and the last chapter, which I will love to give you, is about. We are thinking about. What I started to think about this some years ago, that I feel, or I see, that there are different kinds of domains out there, and they need to be treated differently if you cut them into bounded contexts. And we see that as well in our projects. And this is just like a beginning. We just wrote it down to get people to start to discuss about that. And well, in German, there are already 380 pages, so I don't, this is a lot of stuff. And I hope people will love to read it, because we did a lot of pictures in there and all that. But this is somehow, I promised my husband to never write a book again,
Yeah, well, we're good at breaking those kinds of promises. And I have to say too that you said something about health problems. I just want people to know that Carola is not fading out somehow, like one foot on a banana peel, as we say. But actually, her limitation right now is she might not be able to pitch right-handed in the Major League Baseball in the United States. Okay, no. So but maybe even in 6 months you could pitch they said. In the MLB. So yeah. So
my shoulder will be in a good shape after 6 months. Again.
Excellent. So then, so didn't want to worry anyone there about sometimes you say health problems. Yeah. So you want to write tests, right? You want to add tests. What would make your tests like really understandable? Well, if you didn't have entities that have somewhere between 30 and 100 attributes in a Java class, or properties in a C# class, right? And you scanned through there and you found out, well, look at that. These 10 properties are actually related to each other. So let's put them in a value object and let's give it a meaningful name. And you know what else we could do? We could test that value object.
Exactly.
Then when we add it to our entity, we already know that the value object works. And look at the cognitive dissonance that we've gotten rid of, because now those, let's just pick a number, like those 40 things are now 31 things instead, right? 31 things. So we just eliminate, and you know what? I'll bet we could do that 3 or 4 more times, or even 5, and we might end up with 7 different value objects.
Yes.
And we might have to say 1, 2, 3, 4, 5, 6, 7, just to see that it's not 6 and it's not 8. But I will guarantee you that is way easier to reason about and test right?
Yes.
Than
and our brain
right
will love it. Our brain will love it because it loves chunking.
Yes.
This is exactly what
Exactly. So, very exciting prospect to have that book. Yeah.
And of course, with testing, I go nowhere and tell them to do testing all over the place. It's exactly what you were talking about now. I love this scout rule idea, that you test where you change something, like a scout that puts his tent up somewhere, and when he leaves the next morning, he has to clean up the place. So if you change the software by having domain objects in there, value objects, then you write a test if you change the software. So this is just the point that we are making. It's nothing new, everybody is saying that, but in all this, well, how do I get slowly closer to a good sustainable software following domain-driven design? This is one other little idea,
Yeah, and I think it's also important to understand that 5 things, if 3 things are quite understandable, and 5 things are very understandable as well, and 7 things are a little less understandable, you don't make that say, well, this class now, this entity has too many concepts in it, so we're going to move those out into a different entity, right? We are not talking arbitrary counts here. So does it still fit, the language for that specific, right? Can we still tell stories about that specific part of the language? And does it make sense? Okay, 7 things aren't so bad, right?
Right.
And it's way better than 40. But what if we notice that 2 of those things change or even one of those things change for different reasons than the rest of it? Could we take that one out? But wait a minute, we have 6 instead of 5. Is that bad? No. It is the language and how we think about this and talk about it, right? So it's not a count. It's not a count. It's not the count heuristic, so to speak, or the even number heuristic. So
it's never about numbers. It's about cohesion. No. So if 7 things are a coherent thing, they have to stay together. Yeah. And if it's 8, it's like that.
It's 8. It's 8. Yeah. But 40, you probably got a problem there. That I'm going to just say, a lot of those things that are 40 different things right now are really closely related to each other, or some of them in some way. Okay, so now with these 2 kind of themes, does someone have to start, like before they read your book, do they have to understand these themes right away, or do they start somewhere else and go, okay, we need a prerequisite to this? What? How do they?
No, for me, in all of my books, I think even people who are starting their career in programming can understand a lot, because I'm often looking at our discipline a bit like that. Well, we are like the people who were constructing cathedrals in the 12th century. There are a lot of people who know how to put bricks onto each other, but creating a cathedral that will survive 800 years, like Notre Dame in Paris, or the big cathedral in Cologne. Therefore, you have to have someone who understands huge system construction, huge cathedral construction, And at that time, those were visionaries. That were not. There was nothing about static written down. People couldn't calculate it, measure it, and all that. And we are a bit like that, People know how to put language, statements on top of each other, but a lot of people, that nobody ever showed them what it means to create something huge. And they're doing it all the time in a tempo unbelievable whatsoever. And we have to give them this knowledge, and so they can understand it. They understand these things if you tell them really in a good manner, Yeah.
I think that some people in Barcelona could probably confirm that, right? About that. Well, it's been a real pleasure. And actually, we'll meet in person in less than, what is it, 3 weeks or 4?
3 weeks, yes.
Yeah. So we'll see you at the Como camp and first
and in Hamburg.
And then in Hamburg, And so I really look forward to being overseas again. I've been to South America for first time in, out of the country travel back in November, but wow, I'm looking forward to Europe again. So.
Oh, yes. We are so happy that you're coming. It's such a pleasure to have you here.
Goodbye for now, and we'll see you soon. Bis später. Okay.
Bis bald. Tschüss.